this short video, I try to explain the following task. Task number 1. What is an effective rate? Task number 2. How to estimate EAR. Here EAR stands for effective annual rate. Task number 3. My two-step approach to convert different rate or different effective rate. Task number 4. Formula approach. To explain my two-step approach, I need 2 or 3 formulas. The first one is future value equals present value times 1 plus R with power to n. FV is future value, PV is the present value, R is the effective period rate, N is number of the period. Formula number 2 is related to the power function. For example, if we have A, YA equals XB, then we can solve to get Y. Y equals A, the power is B divided by A. Task number 1. What is an effective rate? We know we have several formulas to calculate future value, to calculate present value, to calculate present value annuity, to calculate present value perpetuity. In this formula, R actually is an effective rate. So generally speaking, for effective rate, we only have 2 cash flow at the beginning of the period and at the end. For example, we bought 1 share, $100 at the beginning of the year and sold it at the end of the year at 110. The effective annual rate is 10%. So this is 10% in 1 year. Example number 2. John just accepted a new job offer in another city. He sold his house about 10 years ago in an excellent location. The selling price was twice of his purchasing price. Assume the purchasing price P now is 2P. So 100% return in 10 years. Example number 3. He placed spot betting yesterday. He lost his $20 bet. So actually it's negative 100% in just 1 day. So all these are effective rate. What is not effective rate? Here is a typical example. APR is 10% and we borrow $100 for 1 year. So actually we have 2 cash flow. After half year, we pay $5 and at the end of the year we pay another $5 plus 100 principal. Task number 2. How to estimate an EAR. Here, EAR stands for effective annual rate. Assume this is APR, so annual percentage rate, and it is 10%. So this is compounding frequency, semi-annually. Okay. So APR 10%, compounding semi-annual. So what is EAR? For Excel, we can use effect EFFECT. The first input variable called nominal rate. So actually a better name should be APR, annual percentage rate. The second one is compounding frequency. So this is APR 10% compounding semi-annually. Its effective annual rate is 10.25%. Task number 3. My two-step approach to convert different interest rate. Step 1. Which effect rate is given? There is no rationality behind this first step, since it is quoted this way by financial institution. Example number 1. The annual rate is 10% compounded semi-annually. The effective semi-annual rate is given and its value is 5%. So that is 10% divided by 2. Why divided by 2? Because it's compounded semi-annually. Example number 2. The annual rate is 10% compounded monthly. It is mean that the effective monthly rate is 0.833%. So actually it's 10% divided by 12. Why divided by 12? Because it is compounded monthly. The general formula is effective rate corresponding to N equals APR divided by N. This is the step 2, from one effective rate to another effective rate. Step 2 has nothing to do with step 1. Just we start from one effective rate. For example, effective semi-annual rate is 5%. What is equivalent effective quarter rate? We use quarter rate as example, so actually we can also calculate effective monthly rate, effective daily rate. Draw a timeline of 1 year with 2 frequency. On top, we have frequency we know, okay, and we know is 5% semi-annual, so the period will be 2. Behind the timeline, we have the rate we want, rate and the current frequency we want to calculate. Because we want to calculate the effective quarter rate, we have 4 period. Okay, so we have timeline. On top of the timeline, we have the number of period for given effective rate. Behind the timeline, we have the rate and the frequency we want to calculate. Then we apply this formula twice. Okay, the first one, we apply this one for the rate we know. Then we apply this rate. We apply the same formula for the rate we want to calculate. We equal them too. So this is rate for semi-annual. So this is rate for quarterly. We equal them, then we solve it. So for this case, the effective quarter rate is 2.46950%. I'm going to use Excel to replicate this result again. Here's task number 4, formula approach. Based on my 2-step approach, we can easily derive the formula. Equation number at the bottom is equation we can apply. Assume that we have APR 10% compounding semi-annually. What is the effective quarter rate? We did it already. Okay, here I just repeat. We apply the following future value formula, equation number 1, twice. First one, future value 1, we know effective semi-annual rate is 5%. Within 1 year, we have 2 periods. Because we want to calculate quarterly effective quarter rate, future value 2 equals 1 plus r raised power to 4. Why 4? Because we want to calculate quarterly effective quarter rate. We equal them, we solve for effective quarter rate. The general formula will base on equation number 2. So N1 equals 2, N2 equals 4, 5% equal APR1 divided by N1. Equation number 3 will be our general formula to convert effective rates. Using Excel, we can easily implement formula approach. Here is the formula we are going to use. Okay, we type APR1 and we assume is 10%. So this is N1. 2. So this is N2. Suppose we are interested in quarterly effective rate. So this is effect R depend on the second frequency. This is 1 plus APR1 divided by N1. Power is N1 divided by N2 minus 1. Okay, so actually APR 10% compounding semi-annually. The effective quarter rate is 2.47%. The beauty of this approach is, suppose we want to estimate effective annual rate, then this is just 1. So this is 10.25%. So we can use effect. So this is 10%. This is N1. And we get the same result. Okay, so let's go back to 4. How about APR2? So APR2 will be effective rate times its compounding frequency. Okay, I'm going to use red one here. Okay, 10% compounding semi-annually is equivalent to 9.878% compounding quarterly. Here we look at an energy. Assume you are going to a bank to withdraw $100. The following amounts are all equal. $100 bill, 1. $50 bill, 2. $5 bill, 20. Which value is the key? Of course, it's total. When this value is fixed for a given count, for example, 50, or denomination, for example, $20 bill, the second value could be determined automatically. The key is total. Now, let's turn to interest rate. For the following table, they are all equal. So actually our starting point is APR is 10%, compounded semi-annually. APR is 10%, compounding semi-annually. The frequency is 2. It is same thing as APR 10.25%, compounding annually. So this is 1. So actually this is a special case. APR is the same thing as effective annual rate. Okay, so actually if you look at the effect rate, so 5%, so 10.25% effective annual rate is the same thing as effective semi-annual rate 5%. It's the same thing as effective quarter rate 2.4695%. In the previous example, when we withdraw money from the bank, the key is total, the total amount. So now the key value is an effective rate. The total amount, we only have one value. However, for the effective rate, we have so many. If you look at here, the second part, we have so many equivalent effective rate. So when effective rate is given, then we can calculate other effective rate. We can calculate all different APR with different compounding frequency. So this is a summary. Challenging task. After watching this video, you can try the following two hands-on exercise. Number 1, assume that John Doe's after-tax annual salary is $60,000. Because of this, every month, his company would pay him $5,000. One day, he was told that in the future, he would receive just one big check at the end of the year, instead of 12 monthly checks. In addition, his company would bear his borrowing cost. Assume his borrowing cost is 4% per year, APR, compounded semi-annually. What is the amount John would receive at the end of the year? Task number 2. How about just 2 checks every 6 months?